Okay. So, so at Oracle, I run the OpenStack for group for the Oracle Linux side. At Oracle, we believe OpenStack to be part of the Linux distribution. So we don't think as OpenStack as a separate distribution. If you have Linux support, you get OpenStack for free. And the Solaris side, they're doing the same thing. So we don't. So even though it's a distro that you can get separately, we don't charge separate for it. We don't actually expect you to think of it as a separate thing. It's just part of Linux, right? Yeah, okay, that we know. So just to, I think I'll skip most of these slides. I'll go very quickly through these. So where OpenStack is today, the adoption that we see as Oracle, since our customers are really enterprise, right? So we don't, all the customers, you think about Oracle and the Oracle database, they're very big customers. They're the enterprise customers that everyone is talking about trying to get to use OpenStack. So the Walmart, the Disneys, the BMWs, they're great. They're a very good starting point for OpenStack. But if you look at what they've done, they all rolled their own, and it took them a long time to do it. It's not something they did in like 2 months. And most of them didn't actually use any distros. They just took upstream. They run it on their own. They have big IT groups that runs it. So that's not really what the distro group is after. But what we're also seeing is talking to these specific companies. If there was a distro or there was actually a way for them to partner with someone else, which some of them did with Mirantis, that's what they would want to do. They didn't actually want to roll their own the whole time. So looking at the adoption challenges that they actually ran into, most of it is like, and I think everyone that actually ever ran OpenStack or even looked at OpenStack knows all of these. The downtime on upgrading, the downtime on installing, the downtime on patching. So that's a funny thing, right? Everyone is talking about upgrading, it takes forever, but no one is really mentioning what happens when there's a CVE for Nova, right? What's if there's a CVE for Keystone? That's downtime that you have to take into account. No one is really looking at that. The distros are starting to look at how the CVE process is going to run and how we can actually help with that. Also, there's a high demand for OpenStack individuals. If you know OpenStack, there's a lot of job descriptions, right? There's a lot of people being hired away from other companies. So one of the challenges that the previous companies mentioned is, yeah, they just trained up an OpenStack guy and then a guy left. So, and then they start training the next guy for OpenStack to run the thing, and then that guy left. So that's another struggle that the bigger companies are actually having problems with. The one on the right, the vendor's proprietary extension, is sort of funny to me. It's like everyone is going to OpenStack because it's open, but how many of the OpenStacks are really open, right? Everyone has a little secret sauce that they add to it. At Oracle, we took the tack, especially on the Linux side, we won't do that. So we will not actually ship anything that you can't get upstream as well. We will not add our special source like we do with the databases or on any of our apps. We try to be as open, we try to be just a community player around the OpenStack group. Okay, so the basic operational issues, as I mentioned, most of it is like this unforeseen downtime during upgrades, installation, reconfiguration, configuration, just keeping your OpenStack running, right? Installing is difficult, upgrading is difficult, running it is even more difficult. A lot of the questions we have from customers when I spoke to them is really around, yeah, we played around with OpenStack. We have it running in a couple of racks. So now what? Now what do we do with all our apps? Especially for a company like Oracle, we have a lot of apps, and most customers want to move those apps into the cloud. They go like, well, that's what everyone is telling us to do. We need to be cloud ready. We need to move our apps. We need to actually just move everything in. And a lot of the times it's not the right answer, right? It's not what you want to do. Another thing that's happening is currently there's no deployment tool that's the leader, right? Every distro has a little bit of a different tool. Like Mirantis has Fuel, Red Hat has now a new one that they're actually using with OOO. So every distro seems to be installed differently, being managed differently, and then all of them are still OpenStack. So and no one is actually being considered as the leader, as the one that everyone is gravitating to. So that brings us to something that we're doing. We decided, well, we're not going to write a separate tool to install, right? We're not going to start again and rewrite Fuel or rewrite whatever, O or something. We want to use something that is already being done in the OpenStack community upstream. So and initially this project was part of O. It's called Cola. What it is, currently it's hosted on StackForge. They did get the approval from the TC to move into the big tent. So they're in the process of moving into the big tent. So it's a full OpenStack project now. And what their plan is, and what they're doing, is actually packaging OpenStack inside Docker containers. So, which is a very interesting concept. Everyone wants to manage Docker with OpenStack. But for this one, we wanted to do something different. We wanted to stop shipping RPMs, because that's what we did in the version 1.0. And it's difficult to upgrade those. It's difficult to maintain those. It's difficult to have people just manage that. So we looked at Cola and we decided, well, that looks like a good idea. And we still think that's the right path. And then we went down this path, and that's just how we're going to ship the future distros for us. We're going to actually containerize OpenStack and ship that as the whole distro. So yeah, so how does Cola help? It's really for deployment, since it's a packaging mechanism. So if you look at the life cycle, it's really, when you start, you're coding, you release. So Cola helps you with the code, the plan, the release, the deploy, the operate, and the monitor. So we will do the building, we'll do the testing, then we'll do the release. You'll do the deploy, the operate, the monitor, and then as you go along with a plan. So at this point in time, as we start pushing out these Docker images, you don't have to upgrade everything at the same time, because now what happened is all the dependencies for each of these projects, like let's say Nova, all of those are now very small microservices, and Nova ends up being around 5 Docker containers. It's not a single one. So if the API has a CVE or has a patch or something that needs to go, we will just patch that. And that's the only one you'll need to upgrade. So you won't have to bring down the whole cloud just to fix one CVE, or to patch the whole environment because one of the base packages have changed. So it's a big advantage that we think that Docker is now bringing into this whole environment. There are still the thing is, well, what happens if the OS is below it, since the Docker image still have an OS component as well? If that has a CVE, yeah, well, that means all the Docker containers is going to get affected. But at least you only have to download that patch once, and then as you deploy and actually just bounce the Docker containers, you can do that in a sequence, not having to bring everything down at the same time. So the architecture to really run this would be something like you have your infrastructure, and everything in green is what we will supply with the Cola process. You'll have a CLI. The Ansible piece is done by Cola, and then the OpenStack service containers, which we use with Cola. So you'll have your infrastructure engineering, your CI and your CD talk directly to the CLI, and it can actually automatically deploy and upgrade stuff as you actually grow your environment. This also makes it easier to grow the OpenStack cloud, right, what you have, since everything is already in these registries. So if you want to add a new server, it's very quickly. You just have to bring that server up to a certain OS and have Docker on it. And then from then on, you don't have to worry what's on it. We will just push down actually Docker will go pull the images down from the local registry and start them up, and you're done. So what does Cola actually do? So this is, as I said, this is a standard project upstream in OpenStack. It provides all the Docker files, right? So it does the Docker stuff, it does the scripts, it does all the tooling around making these Docker containers. The Docker containers that you actually get upstream on the Docker Hub are not intended for production use. they tend to break a lot and change a lot. So that's where at Oracle, what we do is we come in and it says, no, what we'll do is we'll use the Collar way of building these images, and it will be built through the same Docker files, but we'll stabilize them, right? And we will also sign the images as of Docker 1.8. I don't know if anyone saw, but Docker 1.8 has now, how do I call it, a tech preview feature to actually sign the images. So we will do that as well and give that extra knowledge to our customers, like, okay, we created that image, it's not been tampered with. It provides the start scripts and the config scripts that you need for the containers to actually run these. Currently, they do the config external copy and the config external copy once. And what they mean by this is, if you look at the Docker containers, how they work, you need to configure, these containers are bare, right? There's nothing in them when you get them. But to configure them, you need to create, let's take Glance. You need to create that lance.conf file. So Ansible is, Collar supply the Ansible playbooks that will create these glance.conf file. And in glance.conf file, you can have two ways of getting it into the container. Either you copy it once into the container, and then the container is stable, and it's immutable. After that, it will not change again, which is the way that we're going to go with. Because we don't think it's a good idea if someone is running Glance today and someone else just does something to play around, and all of a sudden a new config file goes into Glance, so the next time your image reboots, it has a new config file. It has to be stable and in production environment. But you can do the copy always if something like, I think OOO might use this. I think they were looking at this, where they actually control the config file much tighter. So, or if someone wants to do it by hand, and they always want to be able, in development environments, when you be able to push that config file to do testing. So this is all great, but how do you actually use Collar, right? You have these Docker images, and it's like, I think there's 60 or 70 of them. But you need to be able to deploy these. So that's where the Collar CLI comes into play. So this is something that we've been doing with the Collar community, but it's not currently upstream. We are busy doing the upstream of this. So it will be also part of the GitHub repos. And this is how you will actually, what will allow you to do push or configure the whole environment. So it will be a very simple CLI which you can talk to, script around, or eventually if you want, it will probably have a REST API if you want to actually hook anything else into it. Which will supply a private registry, because a lot of customers, if you have a public cloud or a private cloud, you do not want to go pull images from some Docker Hub registry, right? Most of your Nova nodes would probably not even be able to get to Docker Hub. They would be behind firewalls or whatever. So we will supply a private Docker registry which will then set it up. Also, it will actually make Ansible, the configuration HA capable, since by default Ansible only stores the config files on the local host where you run it. What's nice about Ansible, which I do like, is you don't need anything in your target nodes. It SSH into the target node and do the work. There's nothing required on the target. But that config files that you have, the global.yaml file, and that needs to be HA available. So you can put it on NFS. We will replicate it as well. Okay, so very quickly, how does this actually look like when we build this Docker images? I'm not going to spend a lot of time on it, but essentially what they do is we do this layering. You have a base, which is like the base layer, which all of OpenStack requires, right? Then for Glance, there would be a little bit of more information really for just Glance, on just installing the things that Glance would need, and that would be the Glance base. And from that, you'll have the API or the registry. The other one is, I think, the registry for Glance. So that's like, here's a very quick sample of the Docker files, how they look. They're very straightforward. There's not much in it. I think the most work in doing these were actually figuring out the dependencies and writing the scripts to configure these things. So this is like the API start script for Glance. It's very straightforward. One thing to note is since you have a database, you have to have the bootstrap sequence as well. So the Ansible playbooks are knowledgeable of this. So it will actually bootstrap the first time the container starts up. It will notice it needs to get bootstrapped. Ansible will tell it. It will do the bootstrap to actually populate the database. And from then on, it will never do it again. So putting that all together, this is how the architecture will probably play out, and this is how we envision it's going to play out over the next couple of months. You'll have the management controller nodes where we will run the Docker registry and the Ansible config files. And then you can have as many controller nodes as you want, but you would probably want to limit how many registry nodes you have. That's why we say maximum of 4. And then the compute nodes, again, these are very simple to do. You can do all these by changing the inventory file or using the CLI. So if you want to actually have the compute node, network node and storage node to be the same one, it's very simple to do. Or you can have a controller node that actually have some of the storage stuff or whatever. Not that I would ever actually tell you to do that, because that might not be what you need to do. But you can go ahead and play around, and we will lay out the environment as best as possible and move these Docker images to really lay between the availability zones which are available to do, to duplicate your environment to make sure it's HA. So Docker has a lot of people complaining about it, and a lot of people loving it, right? So there are pros to it. It is immutable. That's what we like, because it's like once you have this image, no one else is going to tamper with it. You can tamper with it, but then it will not be signed anymore, right? So we will know that when you on support. It's portable, so we don't have to worry about the underlying OS that you run. If you run Oracle NX 6 or Oracle NX 7, it's all the same to us. And it's app focused, so so that makes it very nice for the Oracle for the OpenStack pieces, since they're all very tiny, to actually patch them and manage them. There are cons to this, and everyone is saying it's very new, so it's very green technology. Well, Kola is even greener. Liberty would be really the first one I would say anyone should start looking at for Kola. The Kilo release really didn't work that well. They were using Docker Compose at that point, which they've now moved over to Ansible. You couldn't do multi-host installs, so it's very new, and that's why we were in helping them very early on, stabilizing a lot of stuff and getting all the roadblocks out of their way to actually move ahead with this. It is difficult to audit, and debugging inside containers is still very problematic. If you have a container that keeps on bouncing, you can never figure out why. You have to like really spend time to actually look what's happening. So OpenStack inside Docker is Kola. Okay, moving on more to the Oracle side of the world. Another thing that we hear a lot from customers is they want to use the Oracle apps inside OpenStack. So one of the ways that we envision to do this is actually working with our app groups to work with inside Murano. So we already started with a couple of them. So this gives the app group a way to actually integrate into OpenStack without having the customer a very simple way of deploying that app in OpenStack. It's a one-button click. The Solaris group had a demo of this early this year with Mirantis, where they actually showed, and I can't remember the app, but they showed an app that will start up. It will go out to the Oracle database, configure the database, get the database signature back, connection string back, start up the app, and connect to the database. It's very simple, and the customers really like this. It's a very easy way of getting the apps quickly configured. You have a list of them, you click on it, you go off to the races. On a database as a service, we will be supporting Trove. So Trove does have some limitations when it comes to the Oracle database, which is why we have the databases, Oracle as a database service, the 12c1 separate. They don't support the multi-tenancy correctly, completely today. So we are starting to work with the Trove group to see what we will do, how we will actually manage it. But there are also other challenges as to Oracle's database, right? If you have an Exadata, you don't want to have it run. You don't want to hide that within a VM, right? You have your Exadata, which is massive. So maybe you just want to use something like Murano to have your app connect to that Oracle database, and not really try to expose that Oracle database as a service necessarily. So there are options we're looking at. We're working with the database group as well working through this. But yeah, in the future we will definitely have more database as a service on the Oracle 12c. You will see that coming soon. Okay, so high availability. One of the other things that we hear a lot from customers is if they run a cloud, they need to have HA. So for the Oracle distro for OpenStack, what we'll do is we're actually including MySQL cluster, the active-active solution, which we will set up automatically for you. We have the zones, and we will replicate them over all the controller nodes, and use them through the HA proxy to give you high availability. So that gives you that mindset, the peace of mind, because what happened today on OpenStack, since it uses that MySQL database really, really heavily, you can use Galera, but we found that the MySQL active-active cluster is actually a little bit more stable. Okay, some other areas we're working on. So I'm racing through this, so stop me if you have questions. Some other areas we're currently looking at. The integration of OpenStack into private cloud appliance, the Oracle engineered system. So that's where one of the things that we know that customers want, they want a turnkey solution that will give it to them. It's all engineered, all included in one. Cloud Foundry is another thing we hear a lot of interest from customers. So we're looking at Cloud Foundry support and integration. The other one, Microsoft Azure. So everyone is looking at Amazon, right? Everyone wants to have Amazon integration then. So the OpenStack upstream is already have a lot of Amazon work done, but very little Azure work. And we hear from especially the New Zealand and Eurasia countries, they really want to like more Azure integration, so we will look at that as well. The virtual appliances for OpenStack, so again, the database and Oracle Enterprise applications, as I mentioned previously, that's one big focus area for us to get those applications so customers can use them. And then upgrades. So one of the bigger reasons we went through the Cola project as well is for the upgrades. Since it makes upgrades a lot simpler, the image that you have, that container, is self-contained, so bringing one of them down, remove it and because you can pull the latest before you upgrade, right? You have your latest container, you bring it down, you RM it, you bring it up. Your config's already, you can pre-cook your config since it was in that container. So it's a very short period of time that container goes away. So it actually helps you quite a bit, and it makes the upgrade possible. Okay, so wow, I did race through this. So we're in time. So do we have questions? I did race through this. I actually removed a couple of slides, so be happy. Yeah. Yeah, go for it.
I really like containers. I think they are great for apps, for running apps in the cloud, especially because of the performance degradation, which is almost nothing compared with a VM. On the OpenStack deployment and production systems, I don't really get it, especially because it's just your control plane. And it's already complicated in OpenStack, and making it more complicated. I like the concept of crypto for CI, CD, or Cola containers. We do it, but for production deployments, I don't seem to get it. So what would you say is really the benefit of using containers?
The benefit of the container is it's easy. It makes your deployment easier, right? So because if you think about it, we have all that in the dependencies already in Ansible, and we have all these containers that we can push out. They pre-tested, they pre-integrated, and when we push them out, when all your nodes are running them, you know exactly what's running in it. And if there's a patch, that distributing that patch is like today if you use RPM, right? So if the RPM CVE comes out, you have to go to all the nodes. We're like using satellite or anything like that, and it will upgrade all the nodes. That might have a downtime on every of those nodes. With the containers, it's that one container would be affected, right? And you just reboot that one container. It's very quickly, it goes down immediately, comes back immediately. There's no downtime on it. So upgrades is much simpler. And it's a lot easier to expand your cloud now, because to expand the cloud, you don't need to go install like 100 packages on your target node. You just have to get a very simple, very low, small OS and Docker on it. And then from then on, we'll take over and we'll just put your containers there and you're good to go. So it does make your management easier, even though we add some complexity with the containers. And the interesting thing is OO is also moving in the same direction, right? They also want to use containers for their undercloud. Yeah. I don't know. We probably would, but I don't know. I'm more on the OpenStack side. The Linux guys will be able to answer that more easily. Is that it? Cool. Thanks, guys.